Okay, part 2, we're gonna kind of take this, what we learned from this graph, and apply it to this graph now. So again, we're gonna do a rise over a run using 2 points on the line. We'll use these two because they touch grid lines. So my rise from left to right, first one go up and down is down 2. My rise, down 1 is -1. And my run is +2. So here's -1, here's +2. And that actually matches up with the table. Like I kind of mentioned earlier, these are all the same equation, just different representations. So that is going to be for a graph, doing the rise first and the run second. Number 3 is the equation. I know it's kind of at the very, very, very bottom here, but the equation, let's look at this one. Y equals 17x minus 25. I know that equations are written in the form y equals mx plus b. Sometimes you'll see it flip-flopped on you, y equals b plus mx. This is called slope-intercept form, and it's the one that we've mainly been using this year. So, regardless, the number in front of the x, or being multiplied by the x, is the m, and m represents our slope. So here, the number being multiplied by x is 17. So my slope is 17. My other number, well, since we're working with slope, I'm not too worried about it right now, but my other number is my y-intercept. And this is gonna be our b. So in this case, our b is -25. So our y-intercept would be all the way down to -25. So just kind of having it memorized that m represents my rate of change. It represents my slope. Okay, and that's always going to be multiplied by x or some sort of variable, whether that be c, w, whatever the word problem says. But typically it's going to be an x. So m is my slope. Looking back up here at my top equations, well, I know it's going to be in the form y equals mx plus b, where the number being multiplied by x is my slope. So in this case, the number being multiplied by x is -1/2, which again matches up with the rest of the representations. And then I want to do just a quick little side bit. So when we're working with slope of word problems, we have words that indicate slope for us. So these are like what I like to call slope words. And these include words like per. You can also see each, every. Sometimes you'll see it as the word rate. Those are just a few that you can see, and they all represent a change happening over either time or some other variable. So per, you can say that like Johnny earns $5 per hour. That means here's $5 each hour or every hour. So 5 would be that slope. So that equation would be y equals 5 times x, because we know slope is multiplied by x. Now rate, you can say like, if you're talking money, you'll hear the word rate a lot. So what is the cheapest rate? What is the cheapest slope? The lowest slope. But again, all these words represent that number associated with them, like $5 per hour. That 5 is going to be that m in our equation, y equals mx plus b. Now you won't always have a plus b. Sometimes it'll be a +0. If it's +0, you don't need to list it at all. So maybe he earns $5 per hour and starts off at $7 an hour. So since it's starting, that'd be like my y-intercept, but my per hour is still going to be 5. Or maybe he just earns $5 per hour. He doesn't get anything different to start off with. It would just be y equals 5x. So an example word problem for this equation. Let's let's see here. Maybe, I guess this is a bad case, but maybe Krista loses $1 every 2 hours, but she only has 1 to start with. So after 2 hours, I guess she's out, which makes sense. So if this is like my graph, so here's hour 1, here's hour 2. My up and down, my y is at 0, meaning she's out of money. So it's a really silly equation for that one, but that's the first thing that came to my head. So that's kind of just a general overview of slope.